Hey guys, good morning. Welcome to the Aerospace Structures lecture series. Today we are going to see the method of section. This is the one of the method to find out the member forces in the truss member. It is a powerful analytical technique used in structural analysis to determine the internal forces like axial force, shear force, and moments in individual members of the trusses. So it is particularly useful when analyzing specific member of the truss without solving the entire structure. The concept in the method of section, instead of analyzing the entire truss, like we are done in the method of join, the truss can be cut into section at a strategic points, and the internal forces in the cut member can be determined by using of equilibrium equations. It can be solved by very large number of trusses. So let us go with a problem with a great example. There we can understand the how the method of section is works, how we can calculate the equilibrium equations, what is the member forces either in a tension or in a compression by using of method of section. So the steps we need to follow is when some of the members need to be calculated. It is suitable to use this method. However, it can be also used to determine the member forces in the given truss. The method of section consists of cutting through the trusses into two parts, provided that the unknown values are not more than three. So only thing you have to think that the supports and unknown forces and moment can be calculated either in a tension or a compression. These equilibrium equation like f of x equal to 0, f of y equal to 0, summation of m equal to 0 at any point will be used to solve the members. The advantage of this method of section faster than the method of join when analyzing specific numbers. It requires solving fewer equations. It is also useful for large truss number where analyzing all the joints is impartial. The best examples are bridge trusses, roof trusses, and aircraft truss structures like wing spar and internal bracing. So now we'll go with the problem of this given truss member. Here we have the A, B, B, D, C, E, uh, D, E, D, F, C, D, and B, C members. So we have two supports at A and F, and the load is vertical load is 100 kilonewton uh, at the point B, 40 kilonewton at the point E. Whereas at the point C, we have the 80 kilonewton horizontal forces. So at the point A, it is inclined of slope ratio is 2/2 in the vertical, 1 in the horizontal. So from this we have to calculate what are the members like BD and DE and CE member forces individually by using a method of section. The stability and determinacy externally we have three reactions. So R minus 3 equal to 3 minus 3. So it is a 0. So internally we have uh, 9 members and 6 joint. So it is also 9 equal to 2j minus 3. So we'll have 9. So equally, the trust is determined both externally and internally. So the calculation finding the resultant reactions are the supports. Taking moment about F point is um, 2 by the root 5 into RA, the distance, total distance from the F is 12, plus 2 root 2 RA into 2 from the point F, minus 100 into 8, minus 40 into 4, that is a frozen perpendicular distance from the point F. So from here we are going to calculate the resultant value RA equal to 82.6 kilonewton. So coming to point summation of vertical forces F of y equal to 0, RF plus 2 times of 2 by root 5 into 82.6 minus 100 minus 40 will get 66.2 kilonewton as a RF vertical force. Horizontal force, similarly, the equilibrium equation F of equal to 0, finding F of HF equal to 43.1 kilonewton. Now we are going to the second example of the cutting at the point, finding FDB, FDC, FEC. So taking a moment about the point D, we are getting the member forces of FEC, FDB, FCE. Here we are getting FCE equal to 175.5 kilonewton. This is giving a positive average tension. FDC is equal to 58.6 kilonewton is also tension, whereas FDB equal to minus 184.8 kilonewton. This is minus indicates this member carried out a compression load. So here we understand the section 2, finding moment about the point F equal to 0. F of ED will be F of ED into 4 minus 40 minus into 4 equal to 0. FED will be 40 kilonewton. Positive, it is a tension. So some member will get zero load, that is we call it as zero force member. Truss analysis using method of joint can greatly be simplified if one can find determine those member that support on no loading, that is a zero force member. The zero force members can be determined by inspection of the joints. Normally, there are two cases when zero force members can be identified. One is if only two members from a truss joint and no external loads or support is applied, that member must be a zero force member. Second, second case, if three members from a truss joint from for which two or more members are collinear, the third member will be a zero force member, provided no external loads or support reactions acting at that point. So here have the problem number 3. Here we have a sample example. This also helps us to understand how the members carrying a forces uh, individually. Individual members. So this is the sample for your understanding. We just try this at your home. So we'll see in the next class. Thank you.